This is a video on data exploration and analysis using the JMP Student Edition. There are 3 versions of JMP software: JMP Student Edition, Standard JMP, and JMP Pro, the professional version. You could be using any of these 3 versions with students in a classroom setting, but this video is going to focus on special features and how to use the JMP Student Edition. I want to quickly point out some of the differences. JMP Student Edition has a simpler menu, so for example, we'll open the software in a moment and look inside the software, but in the Analyze menu of the software, you can see options like looking at a distribution of data, at fitting a Y variable, a response, by an X variable, a predictor, making tables, fitting larger models, not just one X and one Y, matched pairs analysis, so a paired t-test, some time series, a little bit of multivariate and survival, partition or classification and regression tree type models, and variability charts. So that's the limits of the analytics options in JMP Student Edition. This seems to be plenty of analytics for an intro or an intermediate statistics course, so JMP Student Edition is generally very sufficient for intro and intermediate statistics courses. In addition, in the JMP Student Edition, there are wonderful graphics available, including a tool called the Graph Builder, which is very flexible. So we'll look closer at these in a moment. There are also extra features in the JMP Student Edition, like built-in applets raised up higher in the menu structure, so they're easier to access with your students. The JMP Standard version has additional analytic options, including more predictive models, so neural networks are included in the standard version of JMP, and some other categories with more features under them. The graph menu also has more options. And then the professional version has yet more options, so the Analyze first level of the menu looks really similar to standard JMP, but there's even more options within those categories. The graph options are the same between JMP and JMP Pro. So you can use JMP and JMP Pro if you have a JMP Academic Suite license. These 2 products come with a JMP Academic Suite license, so you could be using either of them in the classroom with that license. But this video is going to focus on that JMP Student Edition, that smaller menu of options, a little bit less in the graphs, but more easy access to some of the special teaching tools like the applets and the calculators. So that's what we're going to talk about in this video. Most of what I cover in this video is available in JMP and JMP Pro. The only differences, the only things that aren't in JMP and JMP Pro that we're going to talk about today are where some of these extra teaching tools are located. So this video will apply to you if you're using JMP Student Edition or JMP Pro, but it's specifically about the JMP Student Edition. Okay, so let's open JMP now. I'm using JMP on a Mac. It runs on both a Mac or Windows, so you can use this with students in a classroom on both operating systems. It looks very similar. Because I'm using it on my Mac, you can see my dock at the bottom has these icons, and so this is how I'm launching it, is clicking on this icon. You can also see that I have 3 identical icons, and as I hover over them, you can see that I have different versions of JMP installed on my machine. I'm going to click on this JMP 14 Student Edition. We are in JMP 14 right now. JMP version 14 came out in March of 2018. Now when I open the software, you see this tip of the day window pop up. The tip of the day, I can ask to show tips at startup. I can enter a beginner's tutorial. I can click through these tips. If I don't want this to keep showing up, when I open it, I can click this off. I can always get back to these tip of the day from the help tip of the day. That will reopen them, and again I can flip through them. So when you want to learn more tricks and tips in JMP, that tip of the day is there. I can also get this home window. The home window lets me see what I've opened recently. So if I wanted to quickly reopen something I've had open recently, I can. And if I have a data set open, I see which open windows I have. I can close this again if I want to get back to it. It's under the window. So there's a JMP Starter window that gives me buttons to create a new data table or open a data table, to click around in different options of platforms I can use in JMP. So I can use this JMP Starter, but I can open that JMP Home window. But I typically use JMP just from the top menu. So I close everything when I open JMP and I just look at this top menu bar. So here I see Analyze. This is what I showed you a moment ago, and these are the options for analytics in JMP. So let's open this big class data right away. And let's go to the graph menu and to Graph Builder. This is a nice flexible platform just to explore what's happening in these data. So in the data we have names of students, we have ages of those students, whether they're male or female, their height and their weight. So I can grab height, for example, and I can look at, does height seem like it's a predictor for weight for these students? And by default, as I'm dragging these variables around, I see that the points show up on this plot and I get this smoother. So this is indicated by this ribbon at the top that shows us plotting options. If I don't want the smoother, I can click on it and it will go away. If I wanted to add a regression line instead, I can click this option and now I have a regression line. Or I could just look at the points. You'll notice for each element from that ribbon that I have on the plot, I get extra stuff that I can do about it. There are lots of options of things that we can do here. Once I add another element, then I get another set of options here. So I could do things like add the prediction interval. I could add an equation onto this plot. I could put the r-squared. I can even write the f-test with a p-value next to this. I could put the root mean square error up there. So I'm going to make this a little bit simpler. I think I'm just going to leave it with the equation and the confidence interval for the fit. So this skinnier confidence interval, the fit confidence interval, this is a confidence interval at each height. It's a 95% confidence interval for the mean. So at height 60, if I trace my cursor up and look at height 60, the distance on either side, that's the 95% confidence interval for the mean weight when height equals 60. You can see that it's skinnier in the middle and wider toward the outside. If I add the prediction interval, that gets even wider. It still actually has that curvy shape where it's wider on the outside, skinnier in the middle, but in this case it's not very curvy, it's closer to a straight line. So I'll just leave the confidence bands and the equation on this plot, and I could add more elements as well. Let's take the age groups. I could group the age across the x-axis. I could group it across the y-axis. I could wrap it around both axes. I could overlay all the age groups on top of each other, and now I get a different equation for each one as well. I could just color the points by the different age groups. I could size the points by the different age groups. I could put each age group on a different page. So if I drop here, and I'm gonna let go now. I've been just hovering my mouse to show you these options, but if I drop it in page, you can see that now it gives me a label at the top that says this is the age equals 12 group, this is the age equals 13, age equals 14, age equals 15, and so on. If I want to undo that, I can click this undo button, or I can grab where I dropped that and pull it back off. So now it's back off of the plot. I could also split these out by sex. So again, I have all these zones. I could drop it on the X groups, the Y groups. I could overlay them on top of each other, just color the points by the sex. I'm going to try overlay and see, do we think that there's a difference in that slope for males versus females? So this is another test I might be interested in. If I'm working with my students on understanding regression, this is a time where I might start introducing the concept of regression by groups, sometimes called ANCOVA, where we put in a grouping variable and we put in a regression type variable, a continuous variable. One thing I want to point out is that all the things that you can do with variables in JMP have to do with whether they're continuous or categorical. And because that's so important to the options that JMP's going to present to you, we see these icons on the side. So this little red icon indicates that this variable, the name variable, is categorical. And this little green ordered bars, this indicates that this is also categorical, but there's an ordering to it. So this is an ordinal categorical, the age variable. If I want to change these, I can right click on the icon and I can change it. So it says it's ordinal. I could make it nominal or continuous instead if I want to treat it in a different way. So if I'd like age to be something continuous, I can change it to a continuous variable. If I go back to the data set, you'll see that that's been updated here as well. So we've got name is categorical, but in name only, so these are nominal. Age is now continuous. Sex is categorical, again nominal. Height is continuous, and weight is continuous. So now let's move into some analytics or some actual statistical analysis that we could do with these data. If I go to Analyze and Distribution, This is sort of the first look at my data. This is looking at distributions of values or distributions of columns, distributions of variables. So I could grab all of my variables here, click this Y button, and now all of these variables will be treated as the Y variable, and I'll get to look at all of these variables. So I'll say OK. I see them stacked on top of each other. There's lots of options for rearranging if I want to unclick stack. Now they'll push them all next to each other horizontally, or I can go back to where I did this. Now, if you were watching me, I did this very quickly, but I used this red triangle next to distributions, and that's how JMP works. It uses these red triangles as drill down menus when you do something in JMP. So I'll go back to that drill down menu for distribution for this platform and say, nope, never mind, I would like to go back to that stacked view. So the first variable in the stack is name. There are 2 people in the data set with the name Robert. I can click on this and I can now see that Robert is highlighted here. There are 2 people with the name Robert. I can see that those 2 Roberts, I can see one of them is 12 years old, one is 15 years old. They're both males. I can see their heights highlighted. So anytime I click something in the data set, it highlights that data everywhere else. This is called dynamic linking, and it's a unique feature in JMP that really helps students to understand their data and explore their data. I can also always grab a plot by this bottom right corner, so I'm going to do that here so that I can see all the names. So here, let's look for John in the data set. Here's John's age, John's sex, John's height. Or I could look for a group of people by grabbing several of these boxes, and now I can see the distribution of this bunch of people I grabbed. So I grabbed a bunch of males and only a couple females, and so I can see their distributions. So that's not quite as interesting looking at the name, and I'm going to tuck name away by clicking this little gray, what we call a disclosure button, to hide this information right now while I don't want it in my way. And so now if I wanted to look at a bigger group, like let's look at all the males, instead of just grabbing them by name, let's look at all the males. Now I can click on the male bar. So here's the distribution of males within the overall distribution of age. And it looks like the ages of males and females are quite similar, which we would expect for just a random mix of males and females in a classroom. This data set is a classroom setting. We can also look at the distribution of the heights, and here I can see that the heights of the males do seem to be slightly shifted up compared to the overall distribution of all males and females. So I'm already beginning to come up with the idea that maybe the heights of males in this classroom is slightly higher on average than the heights of females. The weights, I can also look at the distribution of weights, and honestly I can't really tell from this picture yet if the weights are making a difference. If you want to do something like change the thickness of the bars, that's easy to do in JMP with this little Mickey Mouse glove looking thing called the grabber. If I click on this tool and I click on the plot and push my mouse upwards, it's going to re-bin all the data. So I can easily, and I can do that down here also, I can easily change the bin sizes. There are other ways that I can change the bin sizes as well, but this is a really simple one, is to just use this grabber. Now you can see there's more red triangles for each of these variables. So distribution, the whole platform had the option to change the way I view the data. But then within each variable, I have more options. So I have things like testing a mean for a continuous variable. I could get a confidence interval of any alpha. I could fit a different kind of distribution to this. I could look at a normal quantile plot, or a quantile box plot, or a stem and leaf plot. So there are a lot of options here. Also some extra things I can do on the histogram. I could show the percents in each of the bars, and again, if I use the grabber, these would change. I could ask for the counts instead of the percents. I could change the color. I could change the bin widths here. I could add standard error bars. So there's many things I can do here. Display options, I can change what statistical output I get to see. So do I want different summary statistics? Then I could click on this red triangle next to customize summary statistics and choose to also show the variance and the skewness, or the trimmed mean, or the median, or the mode. So there are many options that I'll find in that red triangle. If I want to now do a test of one mean, I choose the test mean option. And now I get prompted to specify a hypothesized mean. So this is my null hypothesis, my mu naught. So in these data, I'll wiggle this down and we can see that the sample mean was just about 14. So the sample mean age is 14. So let's hypothesize that the average age of the students in this population is 14.5. So we're going to say that's our mu naught. Now JMP gives you a hint. Please enter the true standard deviation to do a z-test rather than a t-test. So if you have a true standard deviation, then you could do a z-test, but we don't have one, so I'm not going to enter anything here, and so I'm reminded that I'll be doing a t-test. If I wanted a non-parametric test, there's also an option here so that I could get this test as well. If I need more help on this topic, there's a little help question mark button that will take me to help on this topic, and I can click OK. And now I get this piece of output that shows me that the hypothesized value here is 14.5, the actual x, so this was mu naught, then x bar, the actual estimate is 13.975, 39 degrees of freedom because there were 40 students in the class minus 1, the estimated standard deviation that makes me do a t-test because that's not the true standard deviation. The test statistic, which is a t statistic, is minus 2.2494. So our value in the null distribution. So this picture here is showing the null distribution centered at 4.5. The little red line here is indicating our actual estimate, 13.975. And the test statistic tells us that that is just about 2.25 standard deviations below the mean is where our test statistic is in the null distribution. So our p-value, if you add up both sides, this side plus this side, is 0.03. If you just look at the upper side, so everything above that red line, that's 0.9849. And if we just look at the lower side, everything below that red line, that's 0.0151. If we want to do yet more to understand this test of a mean, we have a p-value animation built in. So here I could change my null value instead of 14.5. Let's make it a little bit closer. Let's make it really close to 14. So there, that's really close to 14. So if I have a hypothesized mean just about 14, and I just looked at the low side, my p-value is 0.4513. So as I get closer and closer and closer to the estimated value, I get these really high p-values. As I get farther away with my null hypothesis, then I see that that would have been more and more extreme compared to what I was assuming. I can also see how this distribution changes if I change the sample size. So it was 40 because that's our actual sample size, but if I say, what if we had a sample size of 25? How would that change what this picture looks like? So I can watch that change as I update the sample size. There's also a power animation if we want to explore the power of this test as well. Okay, we'll see different options under the red triangle for sex. So here we have things like testing probabilities instead of testing means. So this is going to compute chi-squared tests for p equals p naught. We also have options, again, to put things like the counts or the percents onto our bars and to look at other options for display options. So if I wanted not the horizontal layout, I could have this stacked and so on. So there are lots of things I can customize and change. The next analytics option that we might be interested in is looking at fit y by x. Fit y by x is when we want to actually look at a relationship like a regression or an ANOVA, a t-test, a chi-squared contingency table sort of test, or even a logistic regression, when we've got something with a y variable or a dependent variable or a response variable versus some kind of a predictor variable or an x variable. So I might want to test whether or not the weight is a response to the height. This example is kind of a bad idea example as far as the biology of this. So there might be an association between these things. Certainly the taller you are, that's going to have to add some weight to your body mass, to your weight. but there's not necessarily, we're not proving a causation here. So you want to be cautious with your students, especially with an example like this, that there are many other factors that would play into this relationship. But if we just want to capture what we can from the data that says every time you add an inch to your height, how much on average are we expecting that to add to your weight based on these students, the population of students that we're pulling from here in this sample, then this is a reasonable example to consider a regression kind of concept. So I'm going to say okay in a moment. You can see that this platform will actually give me 4 different types of analyses, all depending on what kind of variables I put here. So because I have continuous response, continuous, so continuous on the y-axis and continuous on the x-axis, I would get this sort of scatter plot and a best fit line situation, so regression. If I had categories as the predictor instead, I'd get an ANOVA or a t-test kind of situation. And if I were predicting something categorical, then I'd be in this chi-squared contingency table situation or logistic regression. I can pull multiple things into these spots, and I'll get multiple analyses out. So this will give me the regression between weight and height, and it'll give me the t-test between weight and sex. So I'll say okay. And the first thing we see from this platform is a picture. Then we use the drill downs to do more things. So I might fit a line in the case of the regression. Here's that linear equation, r squared, some overall fit statistics, overall ANOVA table and p-value, and then the interesting parameter estimates that come out of the linear regression. So you can see these numbers here are the same as in this equation, and we see the p-values for those tests. So here's the p-value testing. Is the intercept equal to 0? And this one is highly significant, so no, the answer is no, this does not seem to be equal to 0. But if you think about, let's expand this axis so we can get the intercept of 0 in here. So here's 0, and then here's 0. So do we believe that that line should have crossed through 0, 0? So that intercept is saying when x is 0, should y also be 0? No, there's no reason why we should believe that. So the test of the intercept is not even that interesting here. Of course it's significantly different than 0 because that relationship, first of all, we don't need it to fit at the origin, and second of all, you can see from the data that no, it certainly isn't going to be. Then the second p-value listed here, this very highly significant p-value for height, is saying, is that slope significantly different than 0? And I can put just the mean line on this plot. So let's go back to a better scale to explore just the data. So this mean line is a flat line. This has slope of 0. So what we're testing with that test of this second p-value test, this is testing, is that slope, which looks to be 3.7 in the data, could that possibly actually be just this flat line? And it appears that it could not, and our p-value tells us, yeah, that's definitely different. That's not just a flat line. If we want to see the confidence curves on this, we can put the fit, that's the mean value, and we can see that that green line does not fall inside of those curves. So we can see the evidence that it's statistically significant. We can also put the individual, so the prediction interval on that, but that is not related to this p-value test. That's just if we have a new height to predict the weight for, where would that confidence interval fall? So we've got a bunch of tools here, and if you're doing more than just regression, there are a bunch of other options like fitting polynomials and fitting more complicated situations from Fit Special. But this is standard what would be covered in a regression course. Under the one-way analysis of weight by sex, we have more options like the pooled t-test or the unpooled t-test, or just looking at means and standard deviations, looking at non-parametric options. So there's a number of things we might be interested here. Let's start with means and standard deviations here. So this is showing for the female group, there are 18 students. The mean is about 100.9 for their weights. For the males, 22 students, the mean is about 108.3 for their weights. So there's about an 8-point difference. So that's a pretty substantial difference. We see confidence intervals, standard error of the mean for each of those two groups. Now let's look at the unpooled t-test. So this tells us, assuming unequal variances, it's in the order of males minus females. So males' heights were higher, minus female heights means we're going to have a positive number. So that difference is not quite 8, it's 7.37. If we standardize that to the t-distribution, so now we've got a t-ratio, so our t-statistic is 1.03. So here we have our null hypothesis that the difference is 0. We have our standard deviation associated with this t-distribution that comes from the data, so the standard error of the difference is this, 7.124. We can see confidence limits, upper and lower confidence limits, and then we can see that the actual observed value, there's a little skinny red line right here at 7.374, which is just above one standard deviation above. So one standard deviation is 7.1. Our difference was 7.3. So we're just a little bit above one standard deviation away. That gives us an upper tail of 15% and a lower tail of 85%. And a two-sided tail of 30%. So certainly we did not find a significant difference. We did not find a statistically significant difference between the heights of males and the heights of females, which seemed a little surprising to me at first because an 8-inch difference, oh, that's not inches. Haha, this is weights. This is not heights. This is weights. So an 8-pound difference from a 100-pound average to a 108-pound average was not a big enough difference given these sample sizes to be statistically significantly different. So in my case, my intuition said that should have been different, and we're seeing the data are saying, nope, these groups overlap too much. There's not enough difference between the two means given the spread of the data in those groups. Now we could do this as a pooled t-test, and the pooled t-test, so the output for this was our means and standard deviations here. This is our t-test with unequal variances, and then above it, all of this output is the pooled t-test, everything that came above it. So it calls it a one-way ANOVA, even though it's actually a t-test. It's a subset of a one-way ANOVA. Again, we get R-squared kind of information. It tells us this is assuming equal variances, this is assuming equal variances. And here's our difference again, 7.3. Standard error of the difference is just a tiny bit less. When we pool the variances, we get a very similar picture, very similar p-values. Then we can also see the overall ANOVA table here. The p-value for the two-sided test is repeated here in the overall ANOVA table. And then we see the means split out for the one-way ANOVA, so for this pooled t-test. And here we see that the means are the same number for the mean as we saw before for the two groups, but the standard error of the mean is just slightly different than the standard error of the mean from our calculations before. And so we can tell students this is because these means and standard deviations are by each group separately. So the female standard error of the mean is calculated alone without using any of the male data. The male standard error of the mean is calculated alone without using any of the female data. But these standard errors are using a pooled estimate. They're using the standard error of all the data from both groups at the same time, and the only reason they're different from each other is because the sample sizes are different. So they're just rescaled to the sample sizes. So I can use this output to really talk about what's happening differently between just calculating the means and a confidence interval at one group at a time versus using all the groups to inform those confidence intervals. And there are a couple other ways to get tests as well. So tests of means, tests of proportions, t-tests, things like that, z-tests for proportions. Those are from the help menu from this calculators option. So if you wanted to do a hypothesis test for one mean or two means, confidence intervals, sample sizes for confidence intervals, you can go directly to the calculators. So if we wanted a test of two means, for example, of raw data. So summary statistics would be if we knew the means and standard deviations of each group. Two samples in two columns would be if we had the men in one column and the women in another column. We have raw data. We have the data in a data table. So I can say okay, and let's say that the column containing the name of the two groups is sex. The column containing the sample values, so we wanted to look at the weights. And then I can say okay. And so it calculates that t-test in this other way. So it's a z-test by default, unless I decide to make it a t-test. When I make it a t-test, you'll notice that it takes away the population standard deviation options. So if I don't know those population standard deviations, I choose this t-test. Then I can ask, do I want the pooled test or the unpooled unequal variances, which is going to be this Welch's Satterthwaite method. So I'll do the pooled in this case. And let's do the two-tailed test. The hypothesized mean mu2 minus mu1 is 0. If I'm testing it, there's no difference. The significance level is 0.05. Here's the sample statistic, the mean for the first group, so that's the women. The second group, here's the mean for the men. Standard deviations, sample sizes for those two groups, and then the estimated difference, the estimated pooled standard deviation. And then here's the actual test result. So based on all those input numbers, we get that the standard error is 7.0477. That's the same that we got from the other platform. The t is then 1.0463. The t critical we would compare to is this value if we want to do it by a critical value, or we can just calculate based on that t statistic what is the p-value, and that's 0.302. There's also this nice little box at the bottom that says reveal decision. When I do that, it says, hey, the decision here is fail to reject the null hypothesis. Okay, so there are a lot of options for how to use JMP for analyzing data, for exploring data. A number of options. I just showed you in the help menu, these calculators are one way to get these tests. We can do those same tests without sample data. So if I wanted to do a test for two means and I just have the summary statistics, then I just enter those sample means, standard deviations, and in every other way this works exactly the same. So let's do it as a t-test again so that I just calculate the sample standard deviation. So using the calculators is one way to do tests. Using the graph menu and the graph builder is a fantastic way to visually explore your data, and you notice you can actually get things like regression out of that platform. And then the analyze options, especially distribution and fit y by x, are really helpful for exploring distributions, finding tests of one mean, tests of proportions. Fit y by x gives us more options like two sample t-tests or even ANOVA with more groups, and regression, things like that. So there's a lot of options here. If you want a paired t-test, that's under matched pairs. And so that asks us for the paired response column and the grouping column. And we have some options under the applets for teaching that I'll talk about in a separate video, including applets on permutation tests and on regression and ANOVA and on those standard tools that you want to teach in an intro statistics course. So I hope you were able to find this video helpful. A few other resources. If you would like a free instructor copy of JMP Student Edition, you can go to this link, jmp.com/get SE-eval. SE for Student Edition, eval for evaluation copy. If you want more licensing and textbook integration information, so just information in general about how to use JMP Student Edition, quick guides, resources, things like that, go to jmp.com/SE. If you want to find more applets, more ideas about how to use JMP in the classroom, ask questions on our community discussion boards, you can go to community.jmp.com. And if you've got a question and you just want to ask us directly, you can go to academic@jmp.com and send us an email at that address. Let us know if there's any way we can support your use of JMP Student Edition in the classroom.